Let us see another example. One box contains 2 red balls and 4 blue marbles. A second box contains 3 red balls and 2 blue balls. What is the probability for drawing one ball from each box? We'll pick 2 red balls. Here with a consideration that the probability of getting a red ball on the first box is 2/6, and the probability of getting a red ball on the second box is 3/5. So the result will be the multiplication of the two, that is 1/5. So the answer will be B, 1/5. And next example, a bag contains 3 fresh and 5 spoiled oranges of equal size. If 3 oranges are to be drawn at random from the bag, what is the probability that at least one of the oranges is fresh? A, 15/28, B, 15/56, C, 45/6, and D, 20/28. Solution. Here, let's talk about combination and factorial on the first case, because the solution is worked under the concept of combination and factorials. What is factorial? N factorial is n multiplied with n minus 1, multiplied with n minus 2, multiplied with n minus 3 until 1. This is concept of factorial. So what's combination? The combination n with r is, or written in this way, combination of n r is n factorial over n minus r factorial, r factorial. This is the concept of combination. Then the solution for the question is probability of 1 fresh orange plus probability of 2 fresh orange plus probability of 3 fresh orange, because we are asking at least 1 fresh orange. So if we are asking at least 1 fresh orange, there are totally 3 fresh oranges. The maximum is 3. So probability of 1 fresh orange is the combination of total number of fresh oranges is 3, and we select 1 fresh orange. Then the spoiled oranges will be 2. That is combination of 5, 2, plus 2 fresh oranges, combination of 3, 2, multiplied with combination of 5, 1, plus 3 fresh oranges, combination of 3, 3, multiplied with combination of 5, 0, over the total number of sample spaces are 8. Combination of 8, so this becomes 30 plus 15 plus 1 over 56. This one becomes 30, this one becomes 15, and this one becomes 1. Let us calculate this one. Combination of 3, 3, multiplied with the combination of 5, 0. 3 factorial over 3 minus 3 factorial, 3 factorial, multiplied with 5 factorial over 5 minus 0 factorial, 0 factorial. So 3 factorial over 3 minus 0 factorial, 3 factorial, multiplied with 5 factorial over 5 factorial, 0 factorial. 0 factorial is 1 in mathematics. This result is 1. This is our solution set. This becomes 23 over 28. So the answer is D, 23 over 28. Another example. A jar contains 3 red and 5 green balls, identical in all aspects except color. If 2 balls are drawn at random, then the probability that the 2 balls drawn are not green is A, 9 over 14, B, 15 over 28, C, 3 over 20, D, 5 over 14. Solution. We are asked to find the probability that not green. Probability of not green means then the complement of green. That is, probability of certainty is 1 minus probability of green. So probability of green is the combination of 5, 2, multiplied with combination of 3, 0, over combination of 8, 2. That is 10 over 28. So the probability of not green is 1 minus 10 over 28. 8, which is 9 over 14. Is it clear? Let's see another example. Out of group of 5 girls and 4 boys, if 3 of them are selected for group work leader, what is the probability that A. All are girls, B. All are boys, C. At least one is a girl? Solution. Let us first discuss or calculate on probability of all are girls. Probability of all are girls means when all are girls, the probability becomes combination of 5, 3 multiplied with combination of 4, 0. This means from the 5 girls, all 3 are girls. From the 4 boys, there is no boys. Over the total sample space is 9, so a combination of 9 with the total number of events that are going to be selected are 3. Then this becomes 5 over 42. The next is probability of all boys. Just reverse it. Combination of 4, 3 multiplied with combination of 5, 0 over combination of 9, 3, which becomes 1 over 21. And the last one is probability at least one is girl. That means just 1 minus probability of all boys. This is at least one is girl. So 1 minus probability of all boys is 1 over 21, which is totally 20 over 21. Probability of at least one girl is 20 over 21.